And welcome back. We're going to go ahead and jump right in with doing some programming examples here. We, of course, are going to look at different things we've done with variables and just kind of recap them. What I've done is I've gone ahead and created a integer and a double here. I got a couple integers. I have quotient, remainder, result, and I have one called number here to act as my double. And so let's just go ahead and first just see what is the output that we're going to expect to see from these various different types here. So for example, if I were to output quotient, what would we expect to see? Would we expect to see an integer value, a double value? What would be that value? All right, and if we go ahead and add, let's say, one for remainder, what's that one going to be? Because if you notice, this one's division, but this one is the modulus operator. So we have a modulus operator here. So modulo is going ahead and doing its thing here. So what should we expect this value here to be? And of course, let's go ahead and add one in for our double down here, simply because we do have a double operator going. And notice that we'd have not just division here, but also multiplication. So I'm going to go have an output number. And then let's go ahead and save that and run our program to see what we would get. All right, so we went ahead and got 2, we got 1, and 6.0. And if we look at that, that's because 7 divided by 3, that would be 3, all right, or 2, remainder 1, because it's 2, but 2 times 3 plus 1 is 7. And 7 mod 3 gives me the remainder, so that's my 1 left over. And with number, we got to answer 6, because again, it's doing 7 divided by 3 times 3. Now, the interesting thing to note here is that even though this is a double, this part right here is still an integer. So this, of course, is an integer, so it's doing 7 divided by 3, which, of course, we found was 2. So 2 times 3 gave me 6, but because the answer is a double, we got 6.0. Now, just for kicks, let's just go ahead and change this here. We'll typecast this into double and just see how that changes our answer. You notice now we get 7.0. All right, because now, instead of getting 2, we're getting 2.5. 2.5 times 3 is giving me the 7.0 that I would otherwise expect. So this is an example right here where typecasting or coercion is going to come in handy here if we want to get a result we're expecting, because even though I did 7 divided by 3, it gave me a integer value here, and even though we were expecting a double answer. So this is very important for us to keep this in mind when we start working with different values. Now, of course, I could just as easily change this by doing this as 3.0, and that, of course, would give me the same exact value. But if we aren't going to put that as 3.0, if we just had this as 3, this, again, is a great way to make sure we are getting the answer we want. Now, let's go ahead and just touch base with results here. So system.out.println, and let's go ahead and put result in here. But what do we want to do with this? Well, let's go ahead and just take result and increment that. All right, and we'll print that out, and we're going to do the same thing, and then, but now let's do, instead of increment, do a decrement here. So we have result plus plus and result minus minus. Now this should mean this should give me 12, and this should give me 10, or back to 11, because of course I am going to increase by 1 and then decrease by 1. And sure enough, we get 12 and 11. Now, what's if I just said, well, I don't want this to decrease by 1. I want this to actually go down further. Well, remember, we do have our combination operators that we could do. So I could make this a minus equals 2, and then this should take it down by 2. So I can go ahead and run that. And so now I got 2, 1, 7.0, 12, and 10. All right, let's just do one more example here. And let's go ahead and do something where we can involve both our integers and our doubles here. So let's just go ahead and grab result, and let's use that with number. So let's go ahead and say we want to do a new value. Let's go ahead and make this one a double. And we're going to call this, let's say, answer. And we're going to have this equal result times number. But we wanted to maybe, let's say, do this with inside a product, right? Maybe we want to do this with an addition operation, or we want to have some sort of thing that's going to give us a value that is much more than simply just 2 operations here. So maybe I want to do, for example, result plus the remainder. All right, if I leave this as is, all right, this is going to, of course, multiply number and remainder first before adding results. And if I run it, I get 17. 0.0. But if I parenthesize this and put parentheses around here, it's going to add results and remainder, or add the quantity here, and then multiply it to give the product. And here we get 77. So you can see there's a big difference when we start using those orders of operations to kind of help dictate different things. And that's going to be very important for us as we move forward with our programming.